Welcome! Today we're going to finish up looking at the different types of reactions. We're going to start by looking at a single replacement reaction, then we'll look at a double replacement reaction, and finally, combustion. I'm going to use letters A, B, C, and D again today to take the place of the elements. So in a single replacement reaction, we're going to have A as its own element reacting with a compound BC. And just like the name implies, A is going to replace B in the compound. So A replaces B, B is now by itself as an element, and AC is formed as a new compound. This is kind of like dancing. You've heard of the term cutting in during a dance. A cuts in on B and C's dance, leaves B by itself, and A and C get to hang out together. Some examples of this reaction. Copper reacting with silver nitrate to form copper nitrate and silver metal. Another example of this reaction would be potassium reacting with water to give us hydrogen gas and potassium oxide. In each of these, we have one thing replacing the other. The copper cation replaces the silver, so then we have copper nitrate and silver being alone by itself as an element. In the second equation, the potassium is going to come in and replace the hydrogen. The hydrogen gas is now by itself, leaving the compound potassium oxide. Our next type of reaction we're going to cover today is going to be called double replacement. In a double replacement reaction, we're going to have a compound switching places with another compound. So we're going to start out with the generic equation AB plus CD. In this type of reaction, two of the elements switch place with each other and we end up with two different compounds. In this case, A and C are going to switch places. C is now with B and A is now with D. If we stick with the dancing analogy, this would be similar to square dancing. You're dancing with your partner, going round and round and round, then you switch partners and dance with somebody else. A couple of equations to look at. We'll start with lead nitrate. And we're going to react the lead nitrate with potassium iodide. And that will give us, if we switch the potassium with the lead, and we'll end up with lead iodide. So this is a double replacement reaction. We call it a double replacement because we have two things replacing each other. And our final type of reaction, it's one you're probably very familiar with. Combustion. It's a reaction most of you have observed. Anytime you've watched a fire burn or drove a car, you've used a combustion reaction. A combustion reaction is defined as any reaction in which something rapidly reacts with oxygen to produce heat and light. An example of a simple combustion reaction, we're going to react methane, CH4, with oxygen. The definition of a combustion reaction, something reacting rapidly with oxygen. And this will give us CO2 and H2O as products of the reaction. So this is just one example of a combustion reaction. There are many, many other ones. For instance, the formation of water was a combustion reaction. We took hydrogen gas, combined it with oxygen gas to make water. Now, even though we classified this one earlier as a synthesis reaction, it is also a combustion reaction because hydrogen is going to react rapidly with oxygen to produce heat and light. This is also a synthesis reaction. So there is some overlap between the between the different types of reactions.